Hello, class. This will continue recorded lectures for section 5.5, a challenging section. And so we are going to talk about three theorems, and I'm going to split them up into three different lectures so it's easy for you to follow. And so the first one is probably the most important of the three we talk about, and it's called the rational zero theorem. And when you start doing these problems from scratch, this is the theorem that you start with. That's why it's the most important. And so the theory behind this is, first of all, what is a rational number? Well, a rational number is a number that can be written as a fraction. So it's the number 1, 2, 3, minus 7, and it could be a third. It could be, 2/5, a variety of different things, but there's no square root. Remember, when you have a square root, that would be an irrational number. So these are just rational numbers. And the idea that if you take the two factors, the leading factor on the leading term and the y-intercept or the constant term, and you do a ratio of them, then these are the only rational x-intercepts or rational zeros that can actually occur. And so here's the official formula, but I think it's easier if we walk through a couple examples. So I'm going to pull up the whiteboard here and show you what we mean by this. So let's go back to say one of the ones that we had in the previous lectures that looks like this. And I said, find all the x-intercepts. And you look at this and say, where do I even start, right? I mean, the idea is it could be any real number that you plug in there, and it could cause for x, and it could cause a value of y of 0. And it's like, where do I start? And that's where the rational zero theorem comes in. And the idea is that you take a ratio of the constant term and you divide it by the ratio of the leading coefficient. And what we mean by factors is this idea of a factor is 6. So what are all the factors of 6? Well, those are numbers that you multiply together that give you the number 6. So we have 6 times 1, and we also have minus 6 times minus 1. And then you would have 3 times 2, and we also have minus 3 times minus 2. So you can kind of see that we would end up with 8 different factors for the number 6. And so what's also nice about this is here, what is our leading coefficient? Well, that's 1. Well, 1's a great number, right? Because it would just be plus or minus 1. 1 times 1 is 1, and minus 1 times minus 1 is 1. So the all possible rational zeros, and these are real numbers that can be written as a fraction, or x-intercepts is what we mean by zeros. It's the ratio of this goes in the numerator and this one goes into the denominator. So it'd be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all divided by plus or minus 1. And so you got to do a little matching up here, right? And so you could see plus or minus 1, when you divide anything into 1, you get the number back. And you could see that when you do the minuses, they'll flip-flop as well. So the possible zeros look like this. Rational zeros, excuse me, look like this. So what's really amazing in this theorem is you went from looking at this equation, right? And saying to yourself, what numbers do I start with to see if there are any zeros? We go from trying infinity number of numbers, right? Down to 8. And so basically what you would do then is take these numbers and plug them in and see if you would get y equals 0, right? And so the beauty of this is you typically start with the easy numbers and you keep plugging them in. And so we'll do that when we do our big example, but if you want to give this a try, plug in -1, -2, and -3, and those would be the 3 zeros that you get. And all 3 of these are actually rational zeros, which is really cool. Okay, let's do one more example. This one will be a little bit trickier, but say like you had something like this. (6x squared plus 7x plus, say, 9. And the question is, what are all possible rational zeros? And so the idea of this is the factors of 9. You would have 9 times 1 and 3 times 3, right? And also -9 and -1 and -3 times -3. So you'll see you always have the plus and minus versions of it. And so in this case, you would have ±1, ±3, and ±9. So what are the factors of 2? Well, 2 is a prime number, which is nice, right? The only even prime number, so it would be 2 times 1 or -2 times -1. And so these factors are ±1 and ±2. And so when you do this, you basically just take the ratio. And so when we have more in the denominator, it's a little bit tricky. So let me walk you through the process that I do. I always start with the 1. 1 ±1 is always going to be a factor. So when you divide that into the numerator, you're going to get ±1, ±2, and ±9. So now we'll take 2 and divide it in and see what you get. So you get ±1 over 2, ±3 over 2, and ±9 over 2. And so now you see, excuse me, we have 12 different options to try. So again, what you would do is start with the easy numbers, and I would leave the fractions to the end, but you would just continue to plug these into the equation for x and try to you would continue to just plug these values in for x and looking for a value of y to equal 0, and do the synthetic or lone division to make the equation simpler and starting to get it in its factored form. So that ends the lecture on the rational zero theorem. You'll see that this will be the first theorem we use when we go through a big example of finding all the zeros. The next lecture, we'll talk about another theorem called Descartes' theorem.